Hello and welcome to the section 4.2 lecture today. Today we're going to talk about constant rates of change. And with that, we're going to be talking about what we call proportional relationships. All of the, the relationships that we've looked at, the unit rates, represent proportional relationships. So let's go ahead and look at this first one. It says that a giant tortoise moves at a slow but a steady pace. It takes the giant tortoise 3 seconds to travel 10.5 inches. So we want to know how far it's going to travel in 1 minute. That's the same as finding the unit rate. So the way we do that, the way we did it in the past, is to look at division. I want to take my 10.5 and divide it by 3. 3 goes into 10 3 times, giving me 9, and when I subtract I get 1, drop the 5, 3 goes into 15 5 times, move my decimal up, goes in 5 times evenly, so we get every second is 3.5 inches. And for that we use division. But we're familiar with that from our previous section. So let's go and complete the table. After 1 second, it's gone 3.5 inches. That's what we just figured out. If we move that along, if it goes another 3.5 inches, it's traveled 7 inches. Another 3.5 inches brings us to 10.5. Another 3.5 brings us to 14. And another brings us to 17.5. So all I did there was added 3.5 every time. And now for each column in the table, I want to find the distance and the time. We did that, okay? Then I want to write each one of these as a fraction and then as a decimal. The way I'm going to write that, I want to put the distance in the numerator and the time in the denominator. So distance will go in the numerator, time will go in the denominator. So we have 3.5 over 1. I also have 7 over 2, 10.5 over 3, 14 over 4, and 17.5 over 5. Do me a favor, pause the video, and divide all these. I would suggest using a calculator. Hopefully you had a chance to do that. So let's go ahead and look at what you got. You should have got 3.5, 3.5, 3.5, 3.5, and 3.5. It's amazing. Okay? That's the idea behind the steady pace that the tortoise was traveling. So what do you notice about the decimal forms? They all equal 3.5. So how do you think the distance the tortoise travels is related to the time? Well, I would guess that it travels, wow, can't even fix that. The pen's getting a little laggy here. 3.5 inches every second. I don't know why I'm dealing with this lag in my pen. Okay. So let's think about this instead. Let's think about the tortoise traveling for 12 seconds. Explain how you could find the distance the tortoise travels. Well, we could either keep adding, right? We could keep adding second after second. Or, there's another way. I know that it travels 3.5 inches every second. So what if I just multiply that by 12? If I think about 3.5 times 12, two times 5 is 10. 2 times 3 is 6, plus 1 is 7. And I have 1 times, actually I need a 0 there. 1 times 5 is 5. And 1 times 3 is 3. So we get 0, 2, add 1, 42. I need 1 decimal place in my answer because I had 1 in my problem. But I should get 42 inches. Sorry about that. So 42 inches in 12 seconds. Okay? And you can kind of think to yourself, does that make sense? Well, it traveled 10.5 inches in 3 seconds. And we're doing that 3-second chunk 4 times. So that sounds pretty reasonable. How would you describe the speed at which the tortoise travels? Just as we thought, 3.5 inches per second. Okay, now let's talk about proportional relationships. It says that a rate of change is a rate that describes how one quantity changes in relation to another quantity. A proportional relationship between two quantities is one in which the rate of change is constant, or one in which the ratio of one quantity to the other is constant. Okay. Any two rates or ratios based on a given proportional relationship can be used to form what we call a proportion. A proportion is a statement that two rates or ratios are equivalent. And there's a couple examples that 6 miles in 2 hours is the same as 3 miles in 1 hour. Or just like fractions, 2/4 is equal to 1/2. So let's look at this example. It says that Callie earns money by dog sitting. Based on the table is the relationship between the amount she earns and the number of days she works, a proportional relationship. Well, if she works 1 day, she gets $16, 2 days, $32, 3 days, $48, 4 days, $64, and 5 days, $80. It turns out that each one of those, if we write them as a fraction of amount earned over number of days, they're all equal to 16/1. And I would kind of leave it to you to check those. If I divide them, do I get 16? And when you compare the rates, all the rates are equal to 16/1, which means that the rate is constant, and the relationship between amount and time, amount of money earned and number of days, is a proportional relationship because it has a constant rate of change of $16 every day. On this problem, it says that the table shows the distance Allison drove on 1 day of her vacation. Is the relationship between the distance and the time a proportional relationship? Or an equivalent question is, did she drive at a constant speed? Okay, well, let's check her speeds. Let's check her speeds over time. So I'm going to go distance over time. I have 65/1. I have 120/2. I have 195/3. I have 220/4. And I have 300/5. And when I do that division, so the next step would be to actually divide these. I get 65, 60, I think 65 again, and then 55, and then 60 again. So it turns out that since I mean, they're not all different, but they're not all the same. That's the more important part, is since they're not all the same, she did not drive at a constant speed. So it's not a constant speed. Her speed fluctuates over the hours. And that means that it's not proportional. Okay. Now we can also talk about writing equations to set these up, to describe these. It says if there is a proportional relationship between x and y. That's the key word. The first word there is so important. If. I can't write an equation for that last example. I can't do it because it's not a constant speed. Okay, your speed fluctuates. So none of this matters for that particular problem. But if there is a proportional relationship, then we can describe that relationship using the equation y equals kx, where k is what we call the constant of proportionality. And it represents the constant rate of change, or the constant ratio between x and y. And that x and y ratio being y over x. Okay. So using the information we have here, we're going to put these numbers into a table. It says that 2 pounds of cashews cost $19, 8 pounds of cashews cost $76, and then it turns out we have a little 3-pound jar here for $28.50. So all that information is in this table. Okay, and then we find those ratios, okay, or find those rates of cost over number of pounds. So at 19 over 2, we have 9.5. At 28.5 over 3, we have 9.5. And at 76 over 8, we have 9.5. So all the rates are equal to $9.5 per pound. And they're constant. Since they're constant, the relationship is proportional, with a constant rate of change of $9.5, or $9.50 per pound. So then we would write the equation. We would say we're going to let x be the number of pounds and y be the total cost. Again, always in these fractions, we have y over x. And that's going to be a very common theme for a while. So we're looking at y over x. So we've got x is the number of pounds of cashews, and y is the cost in dollars. Okay, since the rate of change was constant, we can write the equation y equals 9.5x. This is helpful because now I can figure out how much a 10-pound container of cashews is going to be. Okay, I can find any value I want. I can predict the future, and I can even look in between here. Say they had a 1-pound container of cashews. I could figure out how much that would cost. For this last problem here, we have a school field trip, and it says in this field trip there must be 1 adult if there's 12 students, 3 adults if there's 36 students, and 5 adults if there's 60 students. Show that the relationship between the number of adults and the number of students is proportional. So they're kind of telling us that it's proportional. Now we just want to show that it is. And we want to write the equation. So again, my top row is always x, my bottom row is always y. And to find my k, that constant of proportionality, I want to look at my y's over my x's. So let's look at them all just to verify. This one would be 1 over 12. This one would be 3 over 36. And this one would be 5 over 60. 1 over 12 is as simple as it can be, and its fraction, or its decimal, is not very pretty, so I'm going to leave it as a fraction. I can't move that without moving everything. That's okay. 3 over 36 will reduce if we divide them both by 3. They reduce to 1 over 12. Same thing if we divide both 5 and 60 by 5, I also get 1 over 12. So my k is 1 over 12. So with a k at 1 over 12, my equation becomes y equals, I read it as y equals kx, and I just want to replace my k with 1 over 12. So I'll say y equals 1 over 12 times x. And relating that back to the problem, that means that the number of adults has to equal 1/12 the number of students. Or if you rearrange things a little bit, you could tell that the number of students equals the number of adults times 12. That deals with a little bit of rearranging and recalculating, but it's another way that you could say it. Or that there's 12 times as many students as there are adults. Okay? Last thing we probably need for today, since it was such a big topic of the day, our code word will be proportional. This will be our code word for the day. Proportional. Have a good day, and we'll see you in class.